Have you ever felt a surge of confidence after running your software tests, seeing a high percentage of code covered, only to find a bug lurking in production? It is a common experience, and it highlights a crucial point about how we measure the effectiveness of our testing efforts. The direct answer is that code coverage, while a valuable metric, is not enough for test effectiveness because it only measures what code has been executed by your tests, not how well that code has been tested for correctness. A high coverage percentage can give a false sense of security, leading you to believe your software is more robust than it truly is. The core mechanism behind this limitation is that code coverage tools simply report on which lines, branches, or functions of your code have been touched during test execution. They do not analyze the quality of your tests themselves. For instance, a test might execute a complex function, achieving 100% line coverage for that function, but if the test merely calls the function without asserting any specific output or behavior, it has not effectively validated the function's correctness. It also cannot detect missing logic, meaning code that should have been written but was not, because there is nothing for the coverage tool to measure. To move beyond this limitation, you need to shift your focus from simply executing code to rigorously verifying its behavior. This means designing tests that specifically target boundary conditions, invalid inputs, and a wide variety of real-world scenarios. Ensure that your assertions are strong and precise, validating that the system produces the expected output and handles unexpected situations gracefully. Think about the different states your application can be in and write tests to transition between them, confirming correct behavior at each step. This approach often leads to exploring more advanced concepts such as mutation testing or property-based testing. Mutation testing, for example, deliberately introduces small syntactic changes or mutations into your code. It then runs your test suite to see if the tests fail. If a test suite passes after a mutation, it indicates a weakness in your tests because they failed to catch a potential bug. This gives you a more robust measure of your test suite strength, often referred to as test adequacy. Ultimately, focusing on test effectiveness beyond just coverage empowers you to build more reliable software and have genuine confidence in its quality. By understanding the limitations of basic metrics and actively designing for thorough validation, you are not just ensuring that your code runs, but that it runs correctly under all expected and many unexpected conditions. This proactive approach helps prevent problems, saving significant time and effort in the long run.
If this helps you fix faster, like, subscribe, and keep debugging with us.